Hello again, everybody. Welcome to part 2. Again, this is for Toyota Camry SE. And if you saw my previous video, we were discussing power seats. And we went over a few points and a few parts of these diagrams. Now we're going to continue with other parts, accessories. Now, we talked about sliding position motor. Now we're going to talk about lumbar for the back. We said, let's continue the same way. We always start from here for every motor. We go down here, pin 8. We're not discussing this. We're discussing, go over here. Now, we're going to be discussing this in a second, but we didn't activate the switches. They're open circuit. We're going to discuss this path. Follow this. Pin 5. Follow the arrows. Now, the switch we activated for lumbar. We activated the switch, so as I said before, I printed over here letters to make the contacts more simpler to understand. A, B, C. At rest position, A is connected to C, normal. When we activate the switch, A is connected to B, as so shown by the orange line that I have shown over here. Therefore, current is going to flow here. Remember, the switch is now active here. From B to A, pin 1, come out pin 1, blue line to pin 2, come out here, through the motor, into pin 3. Remember, this is at rest, so this is the position we're in. From D to E, come out here, follow this again, follow the arrows, again, 2. Where do we go? Well, we're not going to go to the switches. Remember, I mentioned in my first video, we always find a path to ground. Where is the path to ground for us? Let's follow the pink. Can we go here? No, we didn't activate the switches for this motor. We're going to go up here, out of pin 11. With seat heater or without seat heater, doesn't matter. Black wire, junction, connection. Pin 8, now pin 3, come out here, and come out here to ground. As I mentioned before, one thing interesting, you will not see relays here. No integration relay module, which Toyota is very, very popular for, which goes bad commonly. And you do not see any blower resistors, any dropping voltage resistors. Full 12 volts to motors, as I have identified over here, as I have shown and printed over here. Full 12 volts. If you go in the other position, everything will go back to ground. Let's activate this one now. Left front power seat lift position, meaning it'll go up or down. Let's put this in the up position. So we will follow the same path. We always begin the same path. This is the common path, as I said before. If all of these don't work, what's common is the fuse and up to here. Otherwise, it splits. So we go from pin 8 to this. 12 volts over here, 12 volts over here, always. The other common thing that I mentioned before is this common line from pin 11. This common ground is for all of these. Therefore, if all of these motors don't work, check out this common ground, pin 11. Check out this from here to pin 8. Now, obviously, if one doesn't work, either the switch on the motor or the connector in between. That's how you analyze. Let's follow this. Here, here, here. Let's go this way. Remember, this is now open. We can't go over here. We didn't activate this one. We activated this one. So therefore, this switch will be in position N to O. P is at rest. We activated it. So now we slid it over this way. Switch is now NO. So now current has a path to flow. Follow this, the blue lines through the motor. And you see it one speed. Come out here, come out here, come out here, come out here, come out here. Now, let's look at something very interesting. Somebody sent me an email, and it was very interesting. It was actually a great question that he asked me. He said, there's another path for current to flow. He said, current can flow here here. Really, but there's one thing that you have to take into consideration. First of all, when you come here, when you come to this node, if you follow it, it goes to ground. If you go this path, through here, then to ground, there's more resistance. We know Ohm's law tells us, basics of electronics, current always takes the path with the least amount of resistance. This is a short to ground, 0 ohms or 0.3 ohms, whatever it is. When current sees this, he sees less a short to ground. He loves it. This would be more resistance. Doesn't like that. The best way to explain it is if you come to a highway and there's traffic all over, but there's another highway and there's no traffic. Which highway would you take? Obviously the one with no traffic. So much for current, the same concept. Current loves it when there's no traffic, 0 amount of traffic. Here, there's traffic, doesn't want it. So, and if you go the other way, when this is activated, you would follow the red, come down here, come down here, come down here. The same concept as before. You have to go over here, 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 and here. So in other words, like I pointed out in the other video, this is spinning both directions, depending on the switches. Depending on one direction, this will be 12 volts. The other direction will be 0 volts. Here, the same side will be 0 volts and it'll be 12 volts. In other words, this can flip-flop the motor from 12 volts to then 0 volts, depending on the switch. And this can go from 0 volts to 12 volts, because now you're connected to the B plus instead of ground. Interesting schematic, very complicated. As I said, the schematics will get much more complicated and much more sophisticated as you see. Hopefully you understand. Pause the video, do whatever you can. I started out with videos from older cars because to build you up and to teach you how to understand the basic concepts. Once you understand the basic concepts, as you see, everything blends in and everything works together. And you'll be able to troubleshoot much more easier. So now if I see my car, none of the motors work, I'll go to the fuse, I'll go down here, I'll go to pin 8, and I'll measure 12 volts over here. I don't have 12 volts over here. That means I'm open from here to here. Right? Or I could be shorted through one of these to ground. That can also be. So now, or the ground opened up over here. If one of my motors doesn't work, this one doesn't work, could be the motor, could be the switch, right? Could be, like we said, could be one of these connectors. But it cannot be the fuse, it cannot be the ground. Otherwise, everything will not work. I hope you enjoyed it, and I hope you tune in. And the next video I'm going to do is about engine performance. And what I did was I overlapped the schematics. Instead of two separate ones, I overlapped them so you can see they are joined. And I can draw the lines much more easier, so you could go from one page to the other page. I don't have a computer to do this, so I have to do it by hand. So as you see, I hope you're enjoying these videos, and it's really a pleasure to explain it to you, and I hope I'm teaching you correctly the best way that I can. So tune in for the next one, engine performance, and I'm going to have actually about 3 or 4 of these overlaid, one on top of the other, so you can understand. Thank you very much.